Malaysia is so hot. I wish I could go somewhere colder. But where?
Bring them to Switzerland.
Oh, I have an idea. Let's visit my hometown Switzerland. It is an amazing place with amazing weather also.
That's a great idea. Let's go. Wow, it's so cold here.
That's right. And there's too many people here too. I wonder what's the population of this country.
Let's try ask that guy. Excuse me, sir. Do you know what's the population here?
Oh, yes. Let me explain to you guys.
Firstly, we will take a look on the tables that comprise the actual population of Switzerland from 2004 to 2023 to the population value generated from the particular mathematical model on the same period. Based on the first table, the actual population shows a clear and steady increase throughout the 20 years. The population rise from 1.3 million in 2024 to 8.8 million in 2023, indicating a consistent growth trend with no significant decrease or irregular manufacturers. This suggests that the country experienced stable demographic and growth over time. In Table 2, the model population values are presented using a time variable. When t equals 0 corresponds to the year 2004. Similar to the actual data, the predicted population also increased steadily, starting from 1.3 million and reaching 8.3 million in t equals 19. This indicates that the mathematical model is effective in capturing the general upward trend in population growth. However, the rate of increase in the module data appears slightly lower compared to the actual population figures. When comparing both tables directly, it becomes evident that while the module follows the same pattern of growth, it consistently underestimates the popular value as time progresses. The difference between the actual and predicted population becomes more noticeable in the later years, showing that the gap widens over time. This suggests that although the model provides a reasonable approximation, it does not fully account all factors influencing population growth. Overall, both tables demonstrate both similar trend, but the actual data reflects faster rate of increase than the module predictions.
For this part, I will explain about the calculation, which is this particular solution is already derived from general solution. Okay, first thing first, we use the given information from the table, which is t equal to 0, which represent 2004, and the population P is equal to this value, and then we substitute the T and P value into the particular solution that we get. Since the exponent 0 is equal to 1, so the equation become this one. So this is the initial population. Next, we use the second data to find the K value. Then we took T equal to 1 and P equal to this value. We substitute into the particular solution formula. Then the next step, we isolate the e power of K by doing the division. To vanish the exponent, we take the natural logarithm on both sides. And finally, we get K is equal to 0.0064. So the final part, since we get the A and K value, we substitute both into the original formula. Thus, this is the final equation.
Using the particular solution that we obtain, we can calculate the future value of the population, which is we take 7 years back, which is t equals to 7 indicates that it is 2036. And then we substitute the t value into the equation, and then we get the future value solution is 7728,208. And then after that, we can also calculate the past value of the population, which is we take 2 years back, which is t equals to -2, which is indicates that 2002. And then we substitute the value of -2 into the equation that we obtain, and then we get the past value, which is the 7295640.
We have plotted three graphs to better visualize the data in the model. The first graph shows the actual population versus year. This graph clearly shows that the population of Switzerland has increased steadily from 2004 to 2023. The second graph shows the estimated population versus time based on our exponential equation. This graph also shows an upward trend indicating the continuous growth. The third graph compares the population trend over time and helps us see how close the estimated values are to the actual values. From these graphs, we can conclude that the exponential model is suitable for representing population growth because the trend is increasing continuously.
First, are the calculated values consistent with the actual values? Yes, the calculated values are generally consistent with the actual values because both follows the same increasing trend over time. This shows that the model is able to represent the overall pattern of the data quite well. Second, what is the percentage error? The percentage error we calculated is 1.11%. This is a very small error, which indicates that the difference between the calculated value and the actual value is minimal. Therefore, the model provides a reasonably accurate estimation. Third, why are there difference between the calculated and actual values? One reason is that the model assumes a constant rate of growth, but in reality, growth does not remain constant and can be affected by many unpredictable factors. In addition, the exponential model assumes unlimited growth, which is not realistic in the long term because resources are limited. This can cause the model to overestimate the actual values. And lastly, the parameters used in the model are often estimated and involve rounding. Even small inaccuracies can become larger over time due to the accumulation of errors. In conclusion, although there are slight differences, the model is still useful because it shows a consistent trend and gives a close approximation to the actual values.
Okay, the next question is, what factors have influenced population growth in the past? In Switzerland, population growth is mainly influenced by migration. Many people move there for better jobs, higher living standards, and safety. However, natural factors like low birth rates and an aging population slow down the population growth. Economic development and government policies also affect migration and overall population. The last question is, what factor may affect population growth in the future? In Switzerland, population change will mainly depend on low birth rate, an aging population, and migration. Fewer people are having children due to high living costs and changing lifestyle, while people are living longer, which increases the elderly population. This may lead to population decline, but immigration can help balance it by bringing in younger workers. Economic condition and government policies also play an important role.
So, in conclusion, Switzerland's population has steadily increased from 2004 and 2023, showing a clear upward trend. Our exponential model closely matched the real data with only a 1.11% error, proving it is a good method to represent population growth. However, the large factors such as migration, birth rates, and aging can cause small differences between the model and actual data. Overall, this project shows how mathematics helps us analyze and predict real-world trends. Thank you.
Oh, like that. Thank you, sir.